Now the next question is question number 4. The perimeter of a triangle is 16 centimeters. If one side of the length is 6 centimeter, what are the lengths of other two sides for maximum area of the triangle? Solution: let length of first side of the triangle is 6 centimeter and length of second side of the triangle is x centimeter. As given, one side is 6 centimeter and we suppose that second side is x centimeter, and the third side of the triangle will become 16 minus 6 plus x, as the total sum, the perimeter of the triangle, as perimeter is, we can mention it out that perimeter is sum of all sides, sum of all sides, as we already know that the perimeter is actually sum of all sides, and sum of all sides is given, which is 16, and one side is also given, which is 6, and we suppose that second side is x, so we can calculate third side of the triangle from here, which is 16 minus 6 minus x, 16 minus 6 minus x, which is 10 minus x. So these are actually our three sides. One is 6, second is x, and the third is 10 minus x. And in this case, as we already know that the perimeter is given and we have to make area of the triangle maximum. Now our required function is actually area. So first we write an expression for area, and for that we make S. In case of triangle, we already know that this is actually formula of S is A plus B plus C. If three sides are A, B and C, then S is actually A plus B plus C divided by 2. And A, B, C are actually the sides of the triangle. And our sides are 6, x and 10 minus x. These are three sides, 6, x and 10 minus x. So S will become 6 plus x plus 10 minus x divided by 2, and S is 16 by 2, because sum of all sides are, these are sides actually, and the sum of sides are given, which is 16. So put the value of the sum of all sides, which is actually 16. So just put the value of this 6 plus 10 minus x, 16 by 2, and S will become 8 centimeter. Why we calculate the value of S? Because area of the triangle is actually square root S into S minus A, S minus B and S minus C, where A, B, C are the sides of the triangle. So just put the value of S, A, B and C. So area will become S is 8, again S is 8, and A, the first side is 6, S again 8, B the second side, which is x, S 8, and the value of C, the value of third side, is actually 10 minus x. So when we make S minus C, then that will become 8 minus 10 plus x. So finally the area of the triangle represented by square root 8 into 2, 8 minus x, x minus 2, which is 16, 8 x minus 16 minus x square plus 2x. So area is 4 into square root minus x square plus 10 minus 16. Now we have to make this area maximum. We have to make this value maximum. So this one is actually function. Now we take help of our second derivative test. So differentiate this area function with respect to x. So differentiate with respect to x, dA by dx is equal to 4, and as the derivative of square root function is 1 by 2, the power is 1 by 2, so 1 by 2, this whole expression, 1 by 2 minus 1, which is minus 1 by 2, and again the derivative of this inner function, which will become minus 2x plus 10. And after simplification, the first derivative is 2, this will be cancelled out, 2 into minus 2x plus 10, and as the power of this expression is minus 1 by 2, we can shift it to the denominator, and that will become square root minus x square plus 10x minus 6. So for stationary points, put dA by dx is equal to 0, and dA by dx is 2 into minus 2x plus 10, and square root minus x square plus 10x minus 16 is equal to 0. As the fraction is 0, so numerator must be equal to 0. Denominator cannot be equal to 0, because this make it to undefined. So numerator must be equal to 0. So that will become 4 into minus x plus 5. And from here we can take minus 2 as a common factor. So 2 into 2 will become 4, and we have left minus x plus 5 is equal to 0. And from here 4 cannot be equal to 0, so we have only minus x plus 5 is equal to 0, and from here x is equal to 5. So this one is the value where the area may be maximum or may be minimum. So put this value into the second derivative. As the second derivative, as to calculate the second derivative of this function is little bit difficult, because this one is actually in the form of fraction. To find the second derivative, that will become a lengthy process. So we can take help from first derivative test, and as we already know that if in the case of first derivative test, we check our first derivative before and after the stationary point. So before x is equal to 5, dA by dx is greater than 0, because the first derivative is actually 2 into minus 2x plus 10, and before x is equal to 5, say we have to check the value at x is equal to 4, and if we replace this x by 4, then that will become minus 8 plus 10, and 10 minus 8 is 2, 2 2s are 4, and similarly in denominator that will return a positive value. And if we check after x is equal to 5, then say we have to check x is let we decide x is equal to 6. After x is equal to 5, let x is equal to 6, then put the value of x is equal to 6 in this first derivative. So that will become minus 12, and minus 12 plus 10 will return a negative value. So before x is equal to 5, first derivative is greater than 0, and after x is equal to 5, the first derivative is less than 0. And if first derivative changes its sign positive to negative, before and after positive to negative, then the area is, or the function is maximum at that particular value. So our value is 5, so, and the function is area, so area is maximum at x is equal to 5. And similarly, if the first derivative changed its sign from negative to positive, then that in that particular case area will be minimum. But in this case, our first derivative changing its sign from positive to negative, then the area is maximum at x is equal to 5. And the required condition is also to make area maximum, and the area is maximum at this value. So our first side of the triangle will become this is actually the given side, 6 centimeter. The second side will become, which was x, and x is 5, so second side of the triangle will become 5, and the third side of the triangle was 10 minus x. So just put the value of x, which is 5. So third side is also become 5. So the triangle having sides 6, 5 and 5, whose perimeter is 16, but the area is maximum.